Hi, this is Kate, and we're working on monomial multiplication and division. This lesson is basically going to take a bunch of little skills that you already have and put them together to solve big, ugly problems like this one. So the first step here is do not panic. We're going to take this one step at a time, and in less than 10 minutes, you're going to be able to do this no problem. It would be very helpful for this lesson if you have some scratch paper and a pencil handy. First question, can you simplify n to the third times n to the fifth? That would of course be n to the eighth because we have 3 n's and 5 n's. We're multiplying those together. Altogether we're multiplying 8 n's. The shortcut here when we're multiplying together the same base is to add the exponents. 3 plus 5 is 8. A little bit trickier question. What's the value of 4 times a squared when a is 3? Please remember your order of operations here. What comes first, multiply or exponent? Think about it and choose carefully. When a is 3, 4 times a squared is 36. We substitute in a 3 for that a, right there. Should we multiply first or do that exponent first? And if you remember your PEMDAS or however you remember it, we evaluate exponents before we multiply. So we'll evaluate the 3 squared first, and then 4 times 9 is 36. Getting a little more complicated here, but you can do this. This is all multiplication here. 5 times x to the fourth times 2 times x to the third. How can we write an equivalent expression in a simpler way? This is equivalent to 10 times x to the seventh. Again, we're just multiplying 4 things together, and when we multiply, we can do it in any order we feel like. Multiplication has the commutative property. So if I rewrite this just by arranging these two terms here, we're multiplying the 5 times 2, that's a 10. We're multiplying x to the fourth times x to the third, so we just add the exponents, and our answer is 10 times x to the seventh. This looks a lot like a previous question, but it's different. What is the quantity 4 times a, the whole thing squared, when a equals 3? This one evaluates to 144. One way to think of this is that anything squared is just that thing times itself. So 4a squared is 4a times 4a. That's the same thing as 16a squared. Since a is 3, we'd want to square the 3 first. We'd end up with 16 times 9, which is 144. This is one way to think about this problem. There is a simpler way though. When we just substitute in a 3 for the a, the parentheses indicate we evaluate the stuff inside them first and then square it. So we do the 4 times 3 first and then square it, and we'd still end up with 144. We're getting a little bit more complicated here, but think about what this means. We're taking a thing, 3y to the fourth, and we're raising the whole thing to the third power. Think carefully about what that means and which expression is equivalent. The equivalent expression is 27y to the 12th. If we raise anything to the third power, that means we multiply it by itself 3 times. 3 times 3 times 3 is 27. Y to the fourth times y to the fourth times y to the fourth. Altogether we're multiplying together 12 y's, so y to the 12th. You may have noticed a shortcut here. When we're taking a monomial like that and raising it to a power, we can raise the coefficient to that power. 3 to the third is 27, and we can multiply the exponents. 4 times 3 is 12. Now I threw a negative in here, so be careful. We're taking negative 4 m to the fifth, raising the whole thing to the second power. Which expression is equivalent? If you missed this one, I expect that you just didn't think about the fact that when we multiply two negative numbers together, the product is positive. Negative 4 times negative 4 is positive 16. And then of course m to the fifth times m to the fifth is m to the 10th. Okay, see how we're building these up to make them a little more complicated over time? Choose the equivalent expression, and just remember your order of operations. You want to evaluate your exponent before you multiply. This is equivalent to 40x to the 18th. We evaluate exponents before we multiply, so that 2x to the 6th raised to the 3rd power, we're going to deal with that first. 2 to the 3rd, and then 6 times 3 is 18. 2 to the 3rd is 8. Now we'll multiply. We've got 5 times 8 times x to the 18th, so we can evaluate 5 times 8. We're going to switch gears a little bit here into division. Think about what y squared and y to the 5th mean. You could also think about your shortcut for dividing the same base, what you do with the exponents, and please choose the equivalent expression. This is equivalent to y to the negative 3rd. So one way to think about this is that w squared is w times w. W to the 5th is w times itself 5 times. Since we're multiplying the top and bottom times the same thing, this is just a fancy 1. W divided by w is just 1. This is also a fancy 1, and when you multiply anything times 1, you don't change its value. So this is the same as just 1 over, and there's 3 w's left over, 1 over w to the 3rd. 1 over w to the 3rd is the same thing as w to the negative 3. The shortcut here would have been to subtract the exponents. 2 minus 5 is negative 3. Okay, see what you can do with this. 12x to the 4th, y to the 4th, all divided by 15x to the 6th, y. This is equivalent to 4y to the 3rd over 5x squared. So one way we can tackle this is to expand the whole thing out, look for all the 1's that don't change the value. We can write 12 as 3 times 4 and 15 as 3 times 5. Those have a common factor. 3 divided by 3 is 1. There are 4 sets of 1's that are made by x over x, and then there's 1 set of 1's that's made by y over y. So what's left over is 4 fifths, 12 fifteenths reduces to 4 fifths, 3 y's on the top, and 2 x's on the bottom, giving us our answer. Another way to think about this is, well, first we want to reduce this fraction. 12 fifteenths is the same as 4 fifths. And then a couple times here we are dividing the same base, so we want to subtract the exponents. 4 minus 6 is negative 2, and 4 minus 1 is 3. It's very typical to be asked not to leave any negative exponents in your answer. Remember, x to the negative 2 is the same as 1 over x to the positive 2. There's a little shortcut you can remember here to help you that goes cross the line, change the sign. So when we move x to the negative 2 to the other side of the fraction line, that's equivalent to x to the positive 2 in the denominator. Cross the line, change the sign. Okay, now here's that big monstrous expression that we started the lesson with. You should now have enough tools at your disposal to deal with this. You're probably going to want to copy this to scratch paper, work carefully one step at a time, and choose the equivalent expression. This is equivalent to 8x to the 18th. This is a really hard problem. If you got it, good job. If you didn't, let's try to understand why. Just thinking about our order of operations, our PEMDAS first, we're going to want to deal with this exponent first. We're raising this 2x to the 3rd all to the 4th power. That means 2x to the 3rd times 2x to the 3rd times 2x to the 3rd times 2x to the 3rd. That's equivalent to raising the 2 to the 4th power and then multiplying the 3 times the 4. So we'll simplify that little part in yellow and just copy the rest of the problem. 2 to the 4th is the same as 16. Next, we can simplify this. We can multiply these two together. 16 times 2 is 32, and since I'm multiplying the same base, I'm going to add the exponents. 12 plus 5 is 17. Now finally, we need to divide. 32 divided by 4 is 8, and then careful here, 17 minus negative 1 is the same thing as 17 plus 1. So we're going to end up with 8x to the 18th. You also could have remembered the little trick here to deal with the negative exponent. Cross the line, change the sign. So this is the same thing as writing x to the positive 1 in the numerator. And then we can see that we're adding together 17 and 1 and getting the same answer. This is Kate, and we've been working on monomial multiplication and division.